hyperboloids. Hyperboloids. Okay, so again we have a pretty cool name. And here we have two divisions of it, or two classifications. So we have one that's called one sheet, okay? And this one looks like, we would have something like a circle here and a circle there or something, and then it kind of goes in, and then it comes out again. So kind of like an hourglass sort of figure there. So we have something like that, and the formula looks like x over a squared plus y over b squared, and then is equal to z over c squared plus 1. So this also can be rewritten with all of the variables on the left side. So then we'd have the same thing, except for we're going to subtract that z over c squared over to the left. So we get something that looks like that, okay? So here, this is a one-sheet thing. And then, so for the other classification would be two sheets, okay? So two sheet, or sheets. And this one looks like an x over a, like the same thing, except for one minor but significant change. So we have that same thing, that same original formula, except for now instead of a +1, we have a -1, okay? And this one, a way to rearrange that would be x over a squared plus y over b squared minus that z over c squared equals -1. So this one looks like kind of similar, except for in the middle it's like detached. It goes away. So we have like a bowl up here, sort of, okay? And then on the bottom we have like another bowl that goes toward the other one, but there's that space in between. So why is that space there? Why is there this gap? So the gap occurs basically because of the formula, right? So if we have, if our z value is less than c, so if z is less than c, so that means that we have, like, for example, 1 over 2 or something, so z is less than c. When that happens, we get that this whole quantity, this z over c squared, is going to be less than 1, okay, less than a +1. So that means if we have less than a 1, subtracting, and then we subtract a 1 from it, that means that the right side is going to be negative, right? But as we see, the left side is always going to be non-negative because we have two quantities squared being added to each other. So we know that the left side is always positive. So we have this disparity here where the equation does not, it doesn't work out, right? So that's why we have this gap when the absolute value of z is less than the absolute value of c, okay? So that's why the gap is there. All right, so now on to another one. This one is called the elliptic, so it has to do with ellipses, and then cone, okay? So this one, the formula for this is x over a squared plus a y over b squared, that's a b, is equal to z over c squared, okay? And here we see there is no plus or minus 1, right? So there's no plus or minus 1, it's not there, there's nothing there. This is just the formula for it. So, since this is a neither plus nor -1, and this is actually, a way to rearrange this is x over a squared plus y over b squared minus that z over c squared is equal to 0, because this is in between -1 and 1, and it is equal to neither value. That means that this is going to be like the middleman. So this elliptic cone is like the middleman, or the in-between, between the one sheet and the two sheet hyperboloids. So what does this look like graphically? So what we're going to have is actually something that resembles both, sort of, but it's kind of like the bridge in between. So we're going to have these circles here, right? So these ellipses may have, I guess, or something like that. And it's basically like an hourglass, but it's squeezed down to a point in the middle, okay? Because it's just equal at this point. Okay, so now on to the next kind of graph we could see. So these are called paraboloids. So paraboloids. So these are kind of like parabolas, right? They should resemble parabolas in some way, or involve them. So there are two different kinds here as well. We have the elliptic kind first. So an elliptic paraboloid has the formula z equals x over a squared plus a y over b squared. Okay, so this one is kind of, it'll look like a bowl, sort of. It's just basically made of parabolas. So x, y, z. So it's made of parabolas, so something like this, but it also is made of ellipses. So it'll be like a bowl shape. So something like that, and then like going down there, all ellipses as well at the level curves. Okay, so this is like a bowl, like a bowl. Okay, and the other kind of paraboloid is a hyperbolic. Hyperbolic. Okay, so this one is kind of like the opposite of an ellipse, right? So we're gonna have that the formula is z equals x over a squared minus a y over b squared. So when you have something like that, you have hyperbolas, which are kind of like look like that a little bit. So our graph will actually resemble something sort of like that. And this one's actually a little bit difficult to draw, just to depict. It's harder than the bowl anyways, but it's going to look something like this, where we have it going down and up. Okay, so we have something like that. And then, hold on here, give me some time. This will look like a saddle. It's supposed to look like a saddle, okay? So this part's like going up in one direction, but it'll also be going down in another direction. So it's a little bit complicated in that sense. So it's going up in this direction, but then it's also going down, okay? So it'll be going down like this as well, okay? So this is more or less, I like their description from the book. It's kind of like a saddle, okay? Like a saddle, okay? All right, so that's it for the paraboloids, and now for one last kind of graph. So what we're going to see is a quadratic cylinder. Quadratic cylinder. And there are actually various types of these, but basically what a cylinder is are their equations. Equations involve are x and y. Involve x and y, okay? So what we have is actually a curve that exists in the xy plane, okay? And that curve is basically just extended upward and downward with vertical lines. So it consists of vertical lines, that's the important part, so vertical lines that go straight up and down from each of those points in the xy plane, and they pass through C. So vertical lines passing through all points on that curve. Through all points on that curve. Okay, so what does this look like? Let's see an example. So the kind of like the traditional cylinder that we know of, that we all know and possibly love, is like a circle on the xy plane, okay? And then if we take a point, let's say, extend a vertical line upward and downward from it, which let's pretend that's a vertical line, and let's take another one, point on the curve, extend it upwards for forever and downwards for forever. How about a point here, extend it upwards and downwards, and similarly everywhere else, right? So we're basically going to obtain this cylinder which mirrors a circle going up and down in all directions, to infinity, up and down, right? So this is a right circular cylinder, right circular, right? That's the formal name for that one that I just drew. There's an elliptic one, which looks like this. So this will be the elliptic. So this is x, y, and z. So if we have an ellipse, let's say, on the xy plane, again, we have our curve starting in the xy plane, draw a line straight up and down at each of these points, up and down, and we get ellipses at every level curve other than the one at the xy plane. Okay, and now I'll continue with a few other ones, and then we'll finish up this video. So another kind of cylinder is the parabolic cylinder. And this one basically is just like a parabola, right? So x and y, and here's our z. So here's, let's say, a parabola, right, on the xy plane. Okay, and then if we extend the lines, if we extend the points on the curve upward and downward, we get something that looks like a parabola at every other level curve as well. So something like that, okay? And they all touch these points, okay? And then one other one, we'll just go over this one, is a hyperbolic cylinder. cylinder. And this one looks like, again, we'll start with a curve on the xy plane, and this curve we're starting with is a hyperbola. So that'll be something like that, and then like that. And again, we'll extend the lines upward, or the points upward and downward with vertical lines. Okay, so something over here looking like that. If we extend it downward, we get another one there. And again, we'll extend these ones up and down a little bit, so we get a curve that looks like, or a surface that looks like this. Okay, so this is our hyperbolic cylinder right here, and this is our parabolic one. Okay, all right, so that does it for this video on the survey of quadratic surfaces. I hope that helps, just as like an overview of all the different kinds of graphs we could see. All right, so again, good luck on the homework, and happy studying.